Okay, welcome to part 2 of my drill press restoration and refurbishing job. This is the power takeoff unit here, or excuse me, not the power takeoff, the power feed. I just have it all cleaned up. I did that off camera. You know how to use a wire brush. I cleaned all the paint off of the 3-stepped pulleys here, cleaned up everything else, make sure all the oil holes are clear, and I'm going to mount this onto the body of the drill press itself so I can more easily finish wiping up, cleaning it off, and cleaning out all these little lubrication holes with a twist drill or something. So here's the power feed assembly. This is all mounted on the drill press itself. Not too much to show here. It's just I didn't take any of this apart. I'm just putting it back together the way it came off. But now you can see how it operates. As it is now, it's in a freewheel mode where this pinion gear can rotate up and down. Then if you want to engage the power feed, you just push this handle down. It engages the worm gear into the drive gear here, and it will continue to drive the spindle down until it hits the little release lever that's back here, and then it kicks it out. At this point, with the power feed assembly on, you can run the counterweight chain through this little support here, up over the pulley that's inside the housing, and down and pin it into the rack that's on the quill there. Okay, so now I'm spending some time on the spindle here and chuck assembly. This portion right here is the part that slides up and down in the quill that I already installed. And on the bottom here, there's a number of washers. This fiber washer goes on top, but on the bottom there's 3 washers. The top washer is just a flat washer. The middle one is the thrust washer. You see all the balls are in here. They're not captive, so be careful, they can fall out. And then the bottom washer has grooves in it, and that's the race around which these balls rotate and roll around. So I'm going to clean all this up. I'm going to take the balls out, make sure those are clean. One just fell out there. Clean all this up, and then this is a threaded shaft collar here. There's a set screw in there, or 2 set screws, and it threads down on this shaft, and it socks everything together and firmly attaches it into that quill so it can travel up and down. So I'm just going to clean it all up, go through it all, make sure it's nice and clean. And one last interesting thing about this is the chuck. It's on a Morse taper. I don't know what number taper it is, but if you look closely at it, this was definitely a farmer fabrication job. You see the chuck has been welded, most likely stick welded, onto a Morse taper, and I guess it works pretty well. When I picked the drill press up, we turned it on, and it didn't seem to have any run out or anything. But I just think that's an interesting little bit of history there. But it shouldn't be any problem at all. Okay, so now I'm going to slide the spindle up through the quill. I put a light coating of grease inside the upper and lower machined portions in here just to give it a little bit of lubrication. It'll get oil eventually when it's running, but just something to get it started. This thrust bearing, I put it together with grease, both to hold all the balls together and also to give it lubrication, of course. And I have to screw off this thrust washer here and the fiber washer underneath it. Take that off and set it to the side. Feed it up there. Like that. Oh, I gotta drop it down. I forgot to put this on. That and that. Now I'll just screw this down by hand. And that's that. I'm going to tighten this a little bit. There we go, a little bit more. I don't think, no, let's see, this can't be too tight. It needs to freewheel, so loosen it just a hair. It spins freely. Now I'll tighten this little set screw with an Allen wrench, and that portion is complete. So now I'm going to install the drive gear, the bevel drive gear on top of the spindle here. But one thing I want to mention, in the first video I mentioned how the Babbitt bearing has these little pucks in it, and I wasn't sure what they were, but I took my knife to them and you could scrape them, and what I believe these little pucks are little bits of graphite, which is the coolest thing. So it's a self-lubricating Babbitt bearing. There is a provision to oil it as well, but way back in the early 1900s they had dry running bearings lubricated with graphite. I think that is the coolest thing. All this new technology we think we have, they figured it out quite some time ago. Now this is the drive key for the bevel gear, and I was trying to figure out what this, it looked like a machined groove there that was on one side but not really on the other. But as it turns out, this is a wear mark, and this side of the key was the drive side. This is where the force to rotate it was pushing on. So of course you see it's ground and worn out, quite a slot in it. Like I've said before, this drill press is just going to be put together and used. I'm not going to be restoring it. So I don't need to buy a new key, because I will just flip it, and now the drive side will be on this nice clean flat side of the key. And 100 years from now, when this key wears out, okay, now you gotta buy a new one. But for now, this will work just fine. Here's the drive gear, and you see this is the provision for oiling. There's a hole here. It's drilled through to a slot, and that slot goes down in here. So you can put a couple drops of oil in there and it'll dribble down into the Babbitt bearing there. Slide it down. Now the key has a little foot on either side, so it's not going to slide out. And we'll just wiggle it in. That's a nice tight fit. I was going to, but I forgot. I was going to just put this in this bearing housing here without the spindle in it, to make sure that the Babbitt wasn't too worn out. But I'm glad I didn't, because it would have just given me another thing to worry about. That's that. That's in there. There's nothing. There's no keyway or anything to retain it. That's just, it is the way it is. Look at that. That spins just fine. Now the next step in reassembly is just to clean up this upper drive shaft here and get it ready to go. The stepped pulley also has a friction fix on it, or what I suppose was a friction fix for what was actually just a loose belt. So of course I'm going to chisel this off and clean all the surfaces of the pulleys up, clean up the gears, clean up the other pulley. This is the power feed pulley. You can see when it was repainted gray, the original color was red. When it was repainted gray, they painted these pulleys as well, which is no good. So I'm going to clean these up, and the drive bevel gear. So here's an interesting little tidbit about the pulley, the upper drive pulley. I was wondering as I was taking this apart how that shaft is lubricated. That's the part of the shaft that drives through here, and the shaft spins inside the pulley if you were in back gear. So I didn't even notice this until I started cleaning it up a bit. You see there's a little screw there and a little screw there, and those screws go to a little passageway that go into yet another Babbitt bearing inside there, and there's the oil hole down in there in the bearing. There are a lot of oil points on this machine, so that's something to keep in mind when you're operating a piece of equipment like this. It consumes oil. There are no greased for life, lubricated for life bearings. You are going to be lubricating them for life. But anyway, I thought that was cool. So I got the upper stepped pulley and this upper drive shaft all cleaned up. The bearing surfaces are nice and clean. There's no nicks or scrapes or anything like that. The power feed pulley was sandpapered and cleaned up. set the there we go. Make sure you don't mess up any of your shims. We'll bolt the caps down and then we'll put on the back gear assembly.